Hello, in this video tutorial, I want to help you how to factor a quadratic when your a value is not equal to 1. I want to begin by mapping out the entire factoring process, and we start with a trinomial of the form ax squared plus bx plus c. For this set of exercises, a is going to be a real number except 1, b and c are any real number. If you want to check out a video that concentrates on factoring quadratics when a is equal to 1, check out my other factoring video on quadratics. In the meantime, let's continue with this idea where the a value is any number except 1. Now the objective is going to be to rewrite this trinomial as the product of two binomials, something that's along these lines. And to do so, I will be making use of a snowflake diagram. I think it will be best if I explain how to use the diagram as we do an example. So let's check out example number 1. Here we have 4x squared plus 19x minus 5. In any factoring problem, we always want to check to see if we can factor anything other than 1. And after a few seconds, we come to the realization that we cannot. So I'll proceed by labeling all of my key terms. My a value is 4, my b value is 19, and my c value is negative 5. Noting that my a value is not 1, I'm going to attempt to factor this with the use of a snowflake diagram. I will apply this to my specific example. And on the top, I need to record the value of the product of a and c. My a value is 4, my c value is negative 5, so the product of a and c is going to be negative 20. 4 times negative 5 gives me negative 20. On the bottom, I'm going to record my b value, and that is going to be 19. And on the upper wings, here and here, we're going to record the a value. The a value is 4. Now I need to find two numbers that when I multiply them together, I'm going to get negative 20, but if I add them, I'm going to get 19. If you have difficulty finding the two values that multiply to negative 20 but add to 19, I encourage you to follow this suggestion. Take the product of a and c, in this case it's the negative 20, and begin to brainstorm different factor pairs. Two numbers that when you multiply them, you get negative 20. So here I know that 5 times negative 4 gives me the negative 20, and I can also play around with the signs. Negative 5 times positive 4 gives me negative 20. I can also use the combination 20 times negative 1. And when you have about 3 or 5 different possibilities, that would be a good time to begin to check and see if one of these pairs adds to the b term, in this case 19. Beginning with the 5 and the negative 4, if I add them, I get positive 1. So this one does not work because I need a 19. Negative 5 plus 4 gives me a negative 1, so this one doesn't work either. Let's try 20 plus negative 1, and here we see that that adds to positive 19. The 20 and the negative 1 are the pair that we need. Once we reach this point, we have to do one final process, and that is to simplify the quote-unquote fractions. This left fraction and this right fraction. Simplifying them, we know that 4 and 20, 4 over 20 can be reduced as a 1 over 5, dividing both the numerator and the denominator by 4. The 4 and the negative 1, that one's already in simplest forms, so we're going to leave it as is. And now I am going to factor, I'm going to rewrite this trinomial as 1x plus 5, or simply just x plus 5, multiplied by 4x minus 1. And that will be the factorization of this trinomial. Before we move on to the next example, there are a few things that I need to point out. The first one is that x is always going to be with the value that you get on the numerator. In this case, x was placed with the 1 and x was placed with the 4. The second thing is that you need to reduce your quote-unquote fractions, because if you do not, then you will get the incorrect factorization. When you do the reductions, do not mix the negatives and the positives. So for example, if you have a negative on the denominator, do not put it in the numerator, vice versa. The negative stays where it's originally placed. And then the final thing is that here we shouldn't really stress about where to place the 20 or the -1. I could have easily put the -1 here and the 20 here. The answer won't change due to the fact that we have the same value right here. Well, the only difference would be that your answer would be written in this order. 4x minus 1 times x plus 5, but due to the commutative rule of multiplication, these two mean exactly the same thing. Keeping that in mind, let us now begin practicing with example number 2. Here we have 6x squared minus 11x plus 4. The first thing I check is to see if I can factor out anything other than 1, and after a few moments I come to the conclusion that I cannot, so I'll begin to label all of my key terms. My a value is 6, my b value is -11, and my c value is +4. I note that my a value is not 1, so I will attempt to factor this out using the snowflake diagram. Applying this to my specific example, I will begin by recording the product of a and c. Basically 6 times +4, that gives me a 24. On the bottom, I record the value of b. Here we have a -11. And on the upper wings, I'm going to record my a value. That's going to be 6. And now I need to find two numbers that when I multiply them together, I'm going to get the value of 24, but if I add them, I should be getting a value of -11. I will proceed by grabbing the 24 and beginning to list different factor pairs. And notice that I have a -11, so I'm going to want to make use of negative values, beginning with, let's see, -12 times -2. That one works. I know that -8 times -3 also works. -1 times -24, and -4 times -6. I'm going to begin to add these and see if I got one that adds to -11. So here, -12 plus -2 is -14, so that one doesn't work. -8 plus -3 gives me the -11. So this is the pair that I need. So here I record -8 and -3. The last thing to do is to reduce the quote-unquote fractions. This one on the left and this one on the right. And we can see that the 6 and the -8, we can reduce that into a 3 over -4, dividing the numerator and the denominator by 2. On the right, we can also reduce this one. The 6 and the -3 can reduce into a 2 over -1, dividing both numerator and denominator by 3. And now we can rewrite this trinomial by factoring it into 3x minus 4 multiplied by 2x minus 1. I want to look at one more example, example 3. Here we have -4x squared minus 8x plus 5. And the first thing that I need to check is to see if I can factor out anything other than 1. Now, a piece of advice I want to give you is that whenever you have a negative on your leading term, factor out that negative. So here, by factoring out the negative, now I have -1 multiplied by, and -4x squared divided by -1 leaves us with a positive 4x squared. -8x divided by the -1 leaves us with a positive 8x. And the positive 5 divided by a -1 is going to leave us with a -5. Whether you are trying to apply the X diagram or the snowflake diagram, your leading term should always be positive. So having this fixed, I can now label my key terms if I zoom in on the parentheses. My a value is 4, my b value is 8, and my c value is -5. I'm going to attempt to factor this with the snowflake diagram since my leading coefficient is not 1. So applying this to my specific example, on the top, I need to record the product of A and C. So 4 times -5, that's going to be -20. On the upper wing, I need to record the A value. That's going to be +4. On the bottom, I need to record the B value. That's going to be +8. And now, I need to find two numbers that when I multiply them together, I'm going to get -20, but if I decide to add them, I'm going to get +8. With some trial and error, we will eventually conclude that the pair that we need is the +10 and -2. 10 times -2 multiplied to -20, but if we add them, they're going to give us a +8. The last thing to do here is to reduce the quote-unquote fractions, so the 4/10 and the 4/-2. I can reduce the 4/10 into a 2/5, dividing both numerator and denominator by 2. And for the right fraction, the 4 and the -2, I can reduce that into a 2/-1, dividing numerator and denominator by 2. Now that I've reduced my quote-unquote fractions, I can rewrite this expression as, we can't forget that -1, and we're going to multiply it by 2x plus 5 multiplied by the 2x minus 1. And simplifying this just a little bit, I can rewrite it as -2x plus 5, 2x minus 1. Now would be a good time for you to practice. I encourage you to try these U-try problems, and the solutions will be presented in 3, 2, 1. I hope you found this video helpful, and I will see you next time.